thank you for making time to talk to us today. Isaac, Nathan, we're excited to hear more about customized assistive devices and everything that you guys do. Please, could you introduce yourself? Let us know your name, which team are you representing, a school, and what is the major you're pursuing.
My name is Isaac Franklin. I'm representing Customized Assistive Devices. I go to George Fox University, and my major is mechanical engineering.
And I'm Nathan Johnson, also from George Fox University, studying mechanical engineering.
Great. Thank you both. So, Isaac, could you tell us a little bit more about what is customized assistive devices?
Mm-hmm. Yeah, so Customized Assistive Devices was birthed from Gamma Prosthetics, which was our school servant engineering team. Um, the kind of concept that we're approaching is making assistive devices for individuals who have handicaps, physical disabilities, whatever they may be. In particular, we're interested in looking at customized mice, computer mice, because we believe pretty much everybody needs access to one of those, and a lot of people have a hard time using them as they are.
Nathan, Isaac just mentioned, and you guys started the project there. Could you tell us a little bit more about is that a part of the school program and how you decided to go into customized mice for individuals with disabilities? How that was the genesis of the project?
So the program within school it's a program that they run all the engineering students through, and they give us topics or different projects that have impacts in different ways and assign a group of several students to come up with some solution to that project. And our group's project was working with assistive devices. So we had a pretty open-ended task of figure out something that can improve the lives of someone living with disabilities. And we went through a list of what are different things that people do on an everyday basis that have pretty big impact to their ability to just live a normal life, and what are things that can impair people from doing that. And what we realized is that using computers is a very central part of modern just life in America. And if you have a hand that for some reason isn't a good fit to your traditional off the shelf computer mouse, that's a big barrier for entry. And in our case, our group was working with one specific client, and she has a hand that's essentially shaped backwards, somewhat like this, due to a muscle disability. And using a computer mouse for her is pretty much impossible just due to the shape of a traditional computer mouse. So what our group did is we designed a custom computer mouse that fit her hand shape, and it worked pretty well. And through that process, we realized that there's a big potential for computer mice that don't fit the standard shape and use case scenarios of what we just find on the shelf nowadays. So what our project is now essentially become is looking at a way to essentially market a customized mouse without needing the design and price overhead of having a custom engineering team spend 2 weeks designing a custom mouse on a one-off basis. So it's a design challenge of customized to a unique use case, and then also figuring out the technology to be able to bring that to market at a reasonable price point.
Thank you. It's interesting because it's something we take for granted on a day-to-day basis that we do activities such as grabbing a mouse, interacting with a computer device, or other activities around the house or the office on a day-to-day life. Isaac, in terms of the market opportunity, the individuals planning to serve and provide customized devices. Tell us about more about your target market. How would you go to market with something like this, which is going to be a lot of one-off pieces? They're going to require a lot of customization, and it's going to be very difficult to mass produce. Could you walk us through about the team's vision about commercializing the idea?
Mm-hmm. Yeah, so what I would say is unique about our process is we want to be able to create any type of mouse with any, depending on the client's unique hand shape or whatever their problem may be. And so a part of our process is turning over the design to the client and allowing them to make whatever shape they want. And as long as the hardware can fit into that shape, then the mouse will be functional. Regarding who we want as a market base, at first, we want to prioritize a market of individuals with handicaps. Perhaps maybe they have arthritis or something preventing a traditional mouse from fitting their hand. Eventually, we believe we could move to gaming mice because there's a big market, just generally speaking, of gamers who want customized equipment. And so we believe we can eventually get to that market as well. But to start, we're going with individuals with handicaps. You asked about mass production. That is really largely what we're trying to tackle. We're trying to create a process in which we can create these customized mice quite quickly. And this is a challenge because each mouse will have a very unique shape and very unique design. But we believe we have a process that can make that happen.
Yeah, it's interesting you mentioned being able to rapid produce a unique shape for a mouse, right, for a computer device. But now with 3D printing computer, where you can use different type of filaments, you can use resins, you can use very advanced forms, scanning, reproducing the scan to be replicated with different materials. It is a big possibility to have an impact in the community, and that will allow you to potentially tap into a larger market. In terms of why we should care about this, Nathan, what is important for society, having customized assistive devices be available for anyone? What is the vision of the team about why society should care that you take this to market?
As I mentioned earlier, with computers being just such a central role of how we interact in society, it's really crucial that we don't have arbitrary barriers to entry for that. For some people, especially, there's one statistic, I don't remember the exact number, but somewhere in the realm of, I think, 40 to 60% of jobs require some degree of computer proficiency. So even being able to hold a job and be able to, say, support a family is something where if you can't use a computer just due to a physical disability, that's just a huge hurdle to overstep. So being able to remove hurdles like that and just give everyone an equal playing field to be able to use a computer to do whatever they want with it is something that we're passionate about and we think will make a big impact in society.
Great. In terms of the insights, what you have learned in this journey, first you went through the server engineering program, and now you're part of InventOR. What is it like to be an innovator? And I start with Isaac and then Nathan.
I would say regarding like what I've learned and what it's like to be an innovator, I would say the biggest thing that I've learned is that you have to be able to clearly identify your problem before you can even begin to attack a solution. In our case, we needed to identify the fact that certain individuals can't use a mouse correctly. And before, when we were working with Servant Team, we were recognizing a very broad variety of topics where these individuals could not do task-specific activities. And so we wanted to make task-specific devices for them. And so I would say the biggest thing that I've learned is recognizing the issue so that we can actually begin to work towards a solution to those problems.
Nathan, in your opinion, what have you learned about being an innovator or think like an innovator?
I'd say the biggest thing that I've taken away from this experience is learning practically how to think outside the box. Because as we've mentioned a couple times, the biggest challenge for this project isn't designing a mouse, it's designing a workflow to be able to design a mouse. Because we want to be able to design a custom mouse for each individual client, but we can't pay an engineer 2 days to design that, or we have a several $1,000 mouse each time. So thinking through just a completely different manufacturing pipeline, a completely different idea of what the parts of a mouse look like, the way it's physically assembled. How can you design it so that each of those custom designs has as many common components as absolutely possible? How can you minimize the customization from a cost perspective, but still have it be a fully custom mouse from a use perspective? It's just a different way of thinking outside of the box that's been just a really good opportunity to experience and work through exactly what that looks like in an innovation setting.
Thank you. In terms of thinking of the future, where do you both see the project could go beyond a school and the competition if you had an opportunity to commercialize it?
I would say that we should be able to hit a target market, as mentioned, of individuals with handicaps and perhaps people with arthritis and whatever it may be. However, we believe that if we were successful, we may be able to bring this anywhere from like various office spaces to the gaming industry, whatever it may be, because if we can actually do this successfully, I would personally love to have a mouse that just fit my hand perfectly. And currently my mouse fits my hand quite well. However, it's not perfect. So there's really no limit to the potential audience for this product if it's done correctly. But again, realistically, I would say our first targets would be individuals with handicaps and then perhaps the gaming industry as well.
Both of you have mentioned a couple times the gaming industry. Nathan, you think the nascent and growing gaming industry will be interested in having a customizable mouse for their experience, or is too far-fetched?
I don't think it's too far-fetched. I have several friends who are in that world pretty extensively, and I follow it pretty closely. And from a market perspective, a big thing in that world is that the idea of being able to custom put together your setup is a big factor of just kind of what that market looks like. So if you're buying a gaming PC, it's all custom. You pick out the parts, you pick out what you want it to look like, you pick out how you want it to operate. Style is a big choice. So that's already something very present within that market. And at the same time, if you're going to spend 3, 4, 5 hours a day with your hand on one device, making sure it's something that's not going to cause, say, repetitive strain disorders, or just basically something that's going to be comfortable and effective is a pretty big deal. Ergonomic mice have been almost a thing created by the gaming industry that are now becoming very common. You see gaming mice in office spaces for exactly that reason pretty often. So I think there's a big potential for our product to also be able to hit that market just because it offers the customizability both from a style perspective and then also from an ergonomics perspective.
Thank you. So our final question is a kind of two-part question is, InventOR Oregon is going to be ending by the end of the month. What are the key takeaways that each one of you have personally for being part of the competition? Have you learned anything new about yourself by accepting the challenge to be part of InventOR?
Okay, so I would say one of the big key takeaways that I've taken is just to be looking forward beyond just the design. There's a lot to actually getting a product into the market, and I was unfamiliar with this process before InventOR, so it has informed me of what that looks like. So just looking beyond just designing something, and Nathan mentioned manufacturability, but then there's also the marketing, and there's like getting funding for your project is all super important key components of actually getting your product onto the market. So I'd say that's one of the big key takeaways I've gotten. What was your second question?
Anything new that you learn about yourself?
I would say what I've learned about myself is that I'm actually not too far away from being able to accomplish this stuff. I wasn't familiar with the process before, but I feel a lot more confident about what it takes to actually move forward and perhaps start a business, get a patent, that sort of thing than I was before. So I learned that I'm not too far from where I want to be graduating school and moving into the industry and the professional world.
One of the biggest things that I've taken away from this experience is having a chance to realize the effort comparison between thinking up ideas and just like running through ideas in your head, and then how much time it actually takes to put those ideas into practice. And it's real easy to spend a week thinking about, oh, what are all the cool ways I could do this? What are all the out of the box different ways I can approach this problem? But then you actually have to sit down and do those things. And that takes more time than sometimes I allocate or expect. So it's a good experience to figure out how to budget the brainstorming time with the practical go make it happen time, and realize that if you put all your time into brainstorming, then you don't have a product at the end of the day. But if you don't do any brainstorming, then you potentially miss out on a different, better way to design the product. So it's a good experience to be able to balance those two. And one of the big things I've learned about myself through this program is probably that I really like the brainstorming part of that. It's really fun to think outside the box. It's really fun to like work with that little mental question of, okay, how can I rethink manufacturing in a different way using modern technologies like 3D scanning and 3D printing, and adding automated computing steps into that pipeline to be able to cost effectively mass produce something that's not mass produced essentially. And it's a really fun thing to think about. And I think I really enjoy tackling problems that are new, creative, and just not standard ones that you would see in the market nowadays.
Great. Thank you both.